Apologies, it's only me here today. David couldn't do it for the talk because there was a COVID case in his daughter class and they need to isolate and he needs to homeschool and everything. The talk is about developing interactive online workbooks for the mathematical education of general STEM students. So here is the outline of the talk. I'll start by introducing the online stack system and very briefly explain what stack is. Then I'll explain the underlying pedagogy of the online workbooks, the basis of our project were the Helm sources for engineering. I'll describe how we transform the Helm workbooks into stack workbooks and how you use them at the University of Edinburgh for our teaching. Assessment sits at the heart of the learning process, and we all know it's a key driver to students' activity. So the main purposes of assessment are to aid learning through formative assessments or high-stakes summative assessments such as exams. Well-designed assessments assure the quality of the course. So to have continuous formative assessment requires time for marking and feedback, and we all found ourselves in that kind of situation. So it's important to use the right tool for the right job. So the School of Mathematics for years now, we're using online assessment for skills-based parts of our courses. So this frees up staff time and students have immediate feedback. So very briefly and without going into technical details, I'll introduce Stack. Stack is an open source software for mathematics and sciences. It's an optional plugin for the Moodle quiz and also for Ilias system. It uses the computer algebra kernel system Maxima. Students can type an answer at the form of an algebraic expression. And with Stack, we can move assessments well beyond multiple choice questions. So Stack has a lot of design choices. Teachers can write their own questions with minimum coding skills. Stack separates validity from correctness. So if the students put like an invalid answer, they won't penalized for that. Multi-part questions are possible to generate, and Stack is very rich in features. So questions can be randomized. We have many different types of inputs, such as matrix, numerical inputs, units. We're able to have partial credits. Plots can be dynamically generated and follow the randomization. We can assess line by line reasoning by equivalence, and the Stack provides full support for scientific units. So Stack was developed back in 2004 by Chris Sanguine, and Tim Hunt and Matti Harula are also lead developers. You will learn more about Stack in the next few days, and I think there is also a Stack training session, but you can also visit the demonstration site. So we have all the tools needed for online assessment of mathematics. How can we use those tools effectively? Our answer to this question was to combine assessment with resources and put the book inside the quiz. All materials are inside the online quiz, the written notes, the video clips, the online assessments. We started this back in 2018, and this is not just a COVID response. In the summer of 2018, we developed the full online course, Fundamental of Algebra and Calculus, that was developed by George Kinnair and Richard Gratwick at the University of Edinburgh. The course is designed to prepare students with a wide range of background for study at the University of Edinburgh. The central idea behind FAC is to take the book and put it inside a sequence of interactive online quizzes. Short blocks of text, examples, interactive applets, videos, all of them are embedded within the sequence of exercises and questions. The quizzes are the organizing structure to promote engagement. The development of FAC was informed by previous educational research on mastery learning. Students need to score more than 80% to pass each week's assessment. I have a link here where you can find an extract from FAC. The extract contains the structure and content of a typical weekly unit. The mathematical education of engineers and scientists is important. Our COVID response to support STEM education was to create high-quality online resources, which are specifically designed for the mathematical education of engineers. For doing that, the knowledge we gained from FAC was valuable. Our work was based on the HELM project. HELM materials were the outline of a 3-year curriculum development project. It was funded by the Higher Education Funding for Council for England. The resources have been produced by teams of writers in 6 universities. Our goal last summer was to combine the underlying pedagogy of FAC with HELM and create comprehensible workbooks for engineers and scientists based on coherent and tested resources. So each workbook and its PhD file had a manageable size, but big enough to be worthwhile. So how we did it? The project was undertaken by a group of interns at the University of Edinburgh and at Loughborough University. Converting HELM into Stack was part of the ACID project at the School of Mathematics. So the group of interns converted HELM source into Moodle or into Stack. This process was done sort of like automatically. And then they implemented questions within Stack. And where possible, they had the sensible randomization. So like we had the HELM static question and students tried to have randomization. So like some versions of the same question would have the same difficulty. The authors also had to write full work solutions for each individual question. So the original HELM only provided the final answer, which could be like a number or just a function. But here in HELM on Stack, we have fully written solutions for each question that provide all the steps that students need to follow. Also, the authors of the questions need to use like sensible potential response trees, generate some deployed variants to verify that all random versions of the same question have the same difficulty. They needed to add test cases in every question and also write some sensible question notes. They followed a strict style guide and to justify consistency. So when each HELM workbook was created, the work reviewed, as David used to say, by local Stack expert. So that was mainly me and Robbie before he embarked into a different role at the School of Mathematics. And then the work was reviewed by the course organizer. So when the PhD students who created the workbooks were implemented the changes we may suggest, then the quiz is tested by a group of undergraduate students who were working on the ACID project. And then hopefully we catch most of the errors. So creating the HELM workbooks was a challenging process. So all authors were new to Stack. From the University of Edinburgh, we had 16 PhD students working on that. So the speed of the working varied significantly. Some students were like hired part-time on that, and they were also involved in other projects on ACID. So it wasn't only making the HELM workbooks. Also, we had varied use of Stack. Like some people didn't put any test cases at the beginning, or they didn't realize what these were about. Even if we had like a Stack training, that was a lot of information for them to digest at the beginning. So they needed a few, probably weeks, to realize all the strength of Stack. Another issue was what fully work solutions mean. A lot of people just put on Stack the HELM answers, which mainly were like a final answer and not the step-by-step solution for the question. Also, the workbooks completed out of sequence. So because the students were working in parallel, each of them were assigned a different workbook. So we could have like workbook 2 and workbook 18 ready and not like 1, 2, 3 in an order. And because we were only a few people supervising the work, we ended up giving repetitive feedback to different authors. But at the end, we managed it. So I have here some screenshot of how workbooks look on the PDFs on Helm and how they look on Stack. Throughout the process of converting from PDFs into Stack, we were faithful to the original source only where possible. So there were cases, especially around questions, where we had to choose a slightly different approach when implementing into Stack. So also on the same time, the Helm workbooks were converted to HTML that was created by the MAS team at the University of Bath. This project was created mainly for accessibility reasons and also shows the significance of Helm workbooks at the UK. So here is an example of task where the Stack version contains some randomization. A key feature throughout the workbooks is that the quizzes are set to adaptive mode. There is a check button at the bottom of the question. When the students complete the questions, they are able to check whether their answer is correct or not and get some feedback, of course, if the feedback is implemented into the question. After submitting the quiz, students have access to fully worked solutions and not only the final answer. So how we use the workbooks in our teaching. So we have two courses specifically designed for engineers and chemists, and they are attended by around 500 students. The course organizer to both these courses is Dr. David Quinn. These courses had already online assessments prior to Helm. So for at least 4 years now, the courses had like Stack quizzes. But this year we restructured the way the courses were delivered. So we used one Helm workbook per week, that is around 3 to 4 sections. The workbook served as the first introduction to each topic. At the end of the week, we assessed the students by a separate Stack quiz. Actually, these Stack quizzes were the same we had like in the previous years. And they also had the short video lectures, which were like 20 minutes to expand on theory, and also the book where they could look on different examples, have a different approach and perspective on the mathematics and reduce screen time. So students' feedback rated the Helm workbooks as the most valuable resource. They really appreciated the check button that they were able to get the live feedback. So what are the future plans? We have many data to look at. Most of the quizzes had more than 400 attempts. We want to understand how students engage with the materials. Did they do the quizzes on time? Were they answering all the questions or just reading through the materials? We also want to identify any weak questions and improve them. And we want to identify where further questions are needed. We are aware that it was impossible to implement everything on Stack last year, especially questions with graphs. This summer, we're working on that, and we try to use some interactive JSX graphs where possible. Then we want to review missing materials and try to complete the set. We only created the workbooks we are needed for our teaching. We would like to convert on Stack the whole Helm if this is possible. And we will release the materials under Creative Commons license at the end of the summer. Actually, 2 interns started working on some of these plans a few weeks ago. So to wrap up, quality online learning materials require a team effort. We need to have a robust online platform such as Stack, well-designed materials, as these are the Helm workbooks, a tested delivery format, and we need to have a style guide and have some agreed delivery standard. So quality materials require people to do the work, and I would like to thank all the Endeavour interns for their hard work last summer.
Thank you, Konstantina. That's really very helpful. Great talk. Thank you. So we have time for questions. If people have questions, could you post them in the EAMS section? I'll just show you I'll post that chat in the chat again. Christian did that earlier, but you could post your questions here. Then we can look at those. While people are having an opportunity to do that, Konstantina, could I ask you what the Helm materials cover? Could you just give, we have plenty of time for questions, could you just give people who've never seen Helm just a very quick overview of where it starts and where it ends and how much is there?
So they have various topics of mathematics. So they start with some very basic algebra. We have complex numbers, we have vectors. Then we have integration, the derivatives, multivariable functions, derivatives of multivariable functions, eigenvalues and eigenvectors, matrices. So oh yes, that's helpful, Chris. You have it handy. So we didn't transform all of them into Stack. Actually, we only done what we needed. For our teaching, there were some chapters in statistics actually, and in data, and probability. I think we have them.
But it's fair to say that what you did do this year was the whole of the first year.
Yes, mainly what the engineers need for first year mathematics.
Right. So there's a question here about how we connect Blackboard to Stack. So how do we connect Blackboard to Stack? So
there is a different link. So probably you know better what is behind the scene, but there is a link that we can put on Learn, and then students immediately go through Learn into the Moodle environment.
Right, so Learn is what we call our Blackboard instance, isn't it? And
yes.
We use the LTI connection to connect one up to the other. So that's a standard LTI connection. Yeah, okay. Thank you, Konstantina. Other questions? How is managing different intern developers? There must have been a range of quality, and what would you do next time?
Oh, so I think, so last year it was the first time we were managing people, and we had a big group of interns. So maybe we didn't know everything of how to make this better. But I think interns probably needed a bit more close management at the beginning. Mm-hmm. We've done a Stack training, but Stack has a lot of things to learn. It has a very deep learning curve. I mean, people need to be aware of everything. They start writing a Stack question, and they need not only write the question in Maxima code, they need to check the potential response trees, and then they believe they have the question ready, they review the question, and then they forget of deployed variables and test cases. Like this extra different, let's say, page that opens when they review the question, people forget it. So I think they need more close management at the beginning, especially spending a bit more time, maybe have more sessions or some sessions of explaining Stack and Maxima, and then explaining test cases and deployed variants, and why it is important to have this. And also like question notes. People didn't know what question notes are about, and they were just putting a list of random numbers, like the variables they used to make the question run. Otherwise, they couldn't save it. But the question notes needs to give information about the question. Otherwise, when you review the question, how you know what the question is about? Like, especially if the person who uses the question is not the person who authors the question, I mean, you can't really understand. I never read like the Stack question. I always go and check the deployed variants.
So what would you do differently?
So probably have less, I don't know if that's possible, have less people working for longer time.
Yeah.
I mean, we were on a rush last time.
Yeah, it's a challenge, isn't it, managing a large team like that? Yeah. Okay. Well, thank you, Konstantina. I hope what you've helped manage is going to become a valuable resource that will rejuvenate the helm materials. When there are people in the audience who wrote some of those helm materials and contributed to them all that time ago. So they have been successful, and that's looks like a very exciting project. So thank you.
Thank you, Chris.
Okay, do we have, let me just see if we have any other questions, because we have a little bit of time. Okay, so there's a question about embedding applets like GeoGebra into Stack. Do you want to speak to that, Konstantina?
So we weren't allowed to have GeoGebra last year, and I think this is about the license. So we're under Creative Commons license, so GeoGebra is not allowed to be. But this year we're trying to have JSX graphs and probably have some interactivity whenever it's possible. That means we need to learn JSX graphs.
That's right, yeah. Okay, so yeah, that was the GeoGebra story. I mean, GeoGebra is excellent, isn't it? But that didn't quite work for us that last year. Good. Well, thank you, Konstantina. Let's thank Konstantina again for that talk. Thank you.